So if I gave you that equation, which is from a previous lesson in chapter 7, I believe, you can write the 27 as 3 cubed. This is to the x. You can write the 9 as 3 squared. This is to the x plus 1. So then I can multiply my exponents, and then I can set the two exponents equal to each other. You with me? Okay. So then I would end up writing 3x equals 2x plus 2, and a slow-witted 10-year-old could solve that equation. Okay. In other words, it's easy. I'm not putting down grade 10-year-olds. I think they're all a little slow-witted. So, what do we do if the equations do not have a common base? So how do we solve this? We could do a trial and error thing. We could use a graphical approach. But what we do is the following. Your first step in this question is to take the base 10 logarithm of both sides of this equation. And introducing a logarithm to an exponential equation results in an equation that's not exponential, because this x as the exponent on this power of 4 to the x can be written in front, and this is no longer an exponential equation because the unknown is not part of the exponent. And I want you to make a mental note to yourself that this thing here is just a number. That's all it is. So if you had an equation that said 3x equals 12, you divide both sides by 3. Here we're saying log of 4 is being multiplied by x. So to get x by itself, we take log of 605 divided by log of 4. And that's the answer. If you wanted a decimal value, then we could certainly do that. We could take the base 10 logarithm of 605 divided by the base 10 logarithm of 4. I want to demonstrate to you that this works. That's what x is. If I were to put that x back into the original equation, I would have to take 4 raised to that answer, and it better give me 605. Otherwise, I'm not telling you the truth here. And it gives you exactly 605. So it's a very slick way. This is the whole goal of today, to get the exponents out of the exponent position and down into the main line where we can deal with them. Unfortunately, they get a little bit more complicated. So if we take a look at this next question, we have 8 times 3 to the 2x equals 568. I would recommend dividing both sides by 8 first, because unless I'm mistaken, 568 divides by 8 an integral number of times. I think 71. Am I right? If you get a decimal, then we're going to have to do something different. So now I have 3 to the 2x equals, I believe I said 71. And this is, it's just a thin slice more complicated than where we started with 1a. Because it's not just raised to the x, it's raised to the 2x. But we can still take the logarithm. It's always the base 10 logarithm. Doesn't have to be, but it's what I would recommend. Log of 3 to the 2x equals log of 71. So now I can move that 2x in front and write 2x log 3 equals log 71. And I'm just going to point something out to everybody, that this 2x log 3 is 2 times x times log 3. That's what it really is. So x is being multiplied by 2 log 3, which means to get x by itself, we can take log of 71 divided by 2 log 3, and then we have our answer. X will be equal to log of 71 over 2 log 3, And everybody should be getting more and more comfortable with logarithms to the point where you see log of 71 over log 9. Like if you were writing an exam and you did this, and one of your choices was log of 71 over log of 9, you would say, oh yeah, that's because I can take this exponent and move it back up on the 3. In fact, some of you might say that instead of moving the 2x down, just move the x down. Any questions with B? Yeah.
So when we're taking the log of both sides, we're multiplying by the inverse, right? Multiplying each side by the...
We're not multiplying each side by anything. We're taking an operation of both sides. I don't want you to use the word multiply. If you're saying we're applying the inverse, kind of, except that since it's a base 10 logarithm and the bases were not tens, it's not a true inverse. We are in some twisted way undoing the exponential nature of it to turn it into a logarithmic. But I wouldn't necessarily think of it that way. I would think of it as, you know what it's very similar to, Arden? When you have a square root equation, a radical equation, you end up at some point squaring both sides. And yes, squaring is the inverse of square rooting, but the motivation is squaring a square root gets rid of it. The motivation here is not quite an inverse. It's simply saying if you take the log of an exponential expression, the exponent moves out in front and it's no longer exponential. Have I answered your question? Okay. Any other questions with B? So, of course, they get progressively more complicated. It's been a while since I've seen a diploma exam, but the last 4 diploma exams that my students have written, this goes back to, 2018, 2019 kind of thing, all have a written response that looks like this in some way. So we have to take the log of both sides, and we will have the log of 4 to the 2x minus 1. And what I'm saying when I tell you that little anecdote is it's likely to be on your exam as a written response here. This type of question is very important. Equals the log. So we're applying a base 10 logarithm to both sides of 3 to the x plus 2. So I'm going to write down the next line and I'm going to purposefully make a mistake. And I want you to think about why what I've written is wrong. So I move the exponent down in front. What's wrong? That's what I'm asking you to think about. And do me a favor just to communicate with me. Put your hand up and then down if you see what's wrong. Dua, can you explain it? Brackets. I need to put brackets around the exponent because it's that entire exponent that has to get multiplied by the logarithm of the base. So these brackets that I'm putting in green are fundamental here. Now, I would say this is one thing that you're going to have to study. You're going to have to maybe make a list of the steps for this type of question and memorize it. Because my experience is some students, they know exactly what to do now. They'll remember it. And others, even though we might do 20 of these, they get to this stage and they go, I don't know what to do. They start dividing and it's wrong. The best way to think of it is those x's, there's 2 x's in this equation that we need to bring together, but they're buried inside of brackets and we can't begin to work on getting x's together until we get them out of the brackets. And what that means is that you have to multiply this log of 4 by the negative 1 and by the 2x. You have to multiply this log of 3 by the 2 and by the x. we have to temporarily anyway make this more complicated by expanding it out. And when we do that, I will get 2x log 4 minus 1 log 4. And we certainly don't need to write the 1 there. Equals x log 3 plus 2 log 3. Now, I'm going to use some highlighting colors here to explain something. This looks like a complicated equation, and it is. I mean, it's not a grade 10 equation or anything, but I want you to notice something, that this 2 and this log 4 are really just a number that is being multiplied by x. This entire negative 1 log 4 is just a number. It's just a number. This log 3 is just a number, and I apologize in advance for the vibrant color. This is another number. So look at what you have here. What you have is a number times x plus a number, or minus a number, equals a number times x plus a number. You don't need to write this down, but if I gave you the following equation, 11x minus 4 equals 7x plus 8, you know how to solve that. You move all of your terms that have x to one side of the equation and all of the terms that don't have x to the other. And that's what we're going to do here. I'm going to move the terms that have x to the left-hand side. So I'm going to get 2x log 4 minus x log 3 equals log 4 plus 2 log 3. So all I've done is I've moved the term that has the yellow highlight in it to the left, making the whole term negative, and I've moved the term that was green to the right, making it positive. Unfortunately, I believe I said in my example 12x and 7x, I think. Was that what I used, maybe? When I wrote, well, imagine it were just numbers. Unfortunately, if you were solving an equation like this, and I've long forgotten what I wrote, so it doesn't really matter. When you subtract that 7x over, you just write 5x, right? Because you know that 12 items minus 7 items is 5 of them. You can't subtract, however, you can't subtract this. How do you subtract that? The answer is you don't, but what you can do is factor the x out. And this is something you have to memorize. At this point, we're going to factor the x out. And have left 2 log 4 minus log 3. And that 2 log 4 minus log 3, everybody, is kind of analogous to the 12 minus the 7 in my example. Equals log 4 plus 2 log 3. And, again, this thing in brackets, 2 log 4 minus log 3, that's just some number. We don't want to calculate it necessarily right now, or maybe even later we don't want to necessarily. But it is, after all, just a number that x is being multiplied by. So x will be equal to this log 4 plus 2 log 3 over 2 log 4 minus log 3. Make sure I wrote that down correctly. Looks good. Can I get you to do me a favor and turn the page? I just want to see what's on the next page. Okay, good. Now, so I'm going to pause there. Any questions with the strategy here? If we look at the whole thing, what we did was we took the log of both sides, The second line here, which has some green brackets, is where we moved the exponent down in front. To go from that to the third line with all the wacky, and I'm going to get rid of these colors now. This was just for explanation purposes. I think it's a little confusing to have it on there. So if you're a highlighter person, I wouldn't necessarily highlight your work on an exam to that extent. To go to the third line, we expanded it out by multiplying those logarithms into the binomials. We move all the x's to one side, all of the non-x's to the other. We factor out the x and divide. Any questions with any of those steps? Okay. So a couple of notes. First of all, that is not likely to be the answer in a multiple choice question or maybe a numerical response question. Maybe it's log of 4 plus log of 9 over log of 16 minus log of 3. And I would like everybody to contemplate where the 9 came from and the 16 came from. All I'm doing, and it should be almost a hello, bonjour kind of thing. Like it's just automatic, you can translate from one to the other. All I've done is I've moved this exponent, this coefficient rather, and written it as an exponent, and I've moved this one up and written it as an exponent. So does that make sense? That might not even be the choice. It might be instead that x is equal to log of 36 over log of 16 minus log of 3. Because log of 4 plus log of 9 is log of 4 times 9, which is 36. Could I have done the same kind of thing with the bottom here? Combine these two? Yes. Why do you think we would not be likely to bring these two together as a single logarithm? Ian?
It looks more complex fraction.
Yeah, that's a good way to put it. It looks like a complex fraction. I would answer it by saying if you did, and it may be on an exam that they write log of 16 thirds, because a difference of logarithms is the logarithm of the quotient. But that's a little clunky, but it's still right. Okay. The other thing I want to point out to you is that at this stage right here, where we went from this line to this line, we made a decision to move the terms that had x to the left. If you had decided to move the terms that had x to the right, then every term would be opposite of what it was, and we would get for an answer instead negative log 4 minus 2 log 3 over log 3 minus 2 log 4. Every single term would be opposite. So there's two answers here. I think this answer that we got is a better answer, and I didn't mention it at the time. But the reason I chose to move the x terms to the left is it would minimize the number of negatives I would have. But maybe when you solve for x, you end up with 2 log 3, imaginary question, minus log 5 over log 7 minus 2 log 5. And if that's the case, then 2 of your terms ended up being negative, 2 ended up being positive, which means if you moved things to the other side, you would have got this. And I'm just mentioning this because on an exam, that can be maybe a little scary that you get the thing on the right but you don't see it there, you need to recognize that it's the same as the thing on the left. All right, we have one last example to do. And this 24 is screwing things up. I will tell you, I already told you that the second part to your assignment 4, which is due Friday, you will know how to do after today's lesson. This question is most applicable to what you're going to have to do for the second part of that question. If we divide both sides by 24, we don't avoid the problem of having a 24 there. You're just going to have it on the bottom of the other side. This is different than this situation where we could divide out that 8 because the other side was just a number divisible by 8. I can't really divide by 24 here. I mean, I could, but it's not going to lead anywhere. Sorry, I'm getting there. There we go. So I won't even bother writing it down. If I divide by 24, I still have a 24 on the other side. So I have to start off by taking the logarithm of both sides. And I guess maybe what I would say to you is everything we are going to do from this point in time is really just algebra. There's no new things I'm teaching you here. We know everything that we have to do, we just have to do it properly. Okay, why can I not move that x plus 2 down in front? So let's get that out of the way first. You cannot move the x plus 2 down in front. Yep. That's right. That argument has 2 factors, and that x plus 2 is only being applied to one of them. It's being applied to the 6 and not the 24. Another maybe way to put it for other people who maybe need a second viewpoint is the rule is log base whatever, and this is going to be base 10, so I'm not even going to put the 10 in, of m to the n is the same as n log of m. So it only works if the argument is a base raised to an exponent. And this argument here is not a base raised to an exponent. It's a number times a base raised to an exponent. We still want to get that exponent down in front, but we can't do it yet. However, I can write this as log of 24 plus log of 6 to the x plus 2 equals log of 2 to the x plus 3. And now I can, so I've used the product law, which says the logarithm of a product of 2 things is the sum of the logarithms of those things. And now I can move that x plus 2 down in front, and I will have log of 24 plus x plus 2 in brackets log 6 equals x plus 3 in brackets log 2. So let's see if you've learned something from the previous lesson. I cannot move the previous question. I cannot move the x terms to the same side yet. It'd be useless. What do I have to do before I start moving those x terms around? Leslie? Not factor. We save the factoring for later. I think you know, but you're just using the wrong word. We have to expand it out to get the x's separate from the other numbers. So what I need to do here is take this and multiply it in, and take this and multiply it in. How many of you see, after doing that, and if you don't, that's fine, but how many of you see after doing that, we're going to proceed doing the exact same thing we did in the last example, but instead of having 4 terms to work with, we're going to have 5. That's the only difference. It's because of that 24, it screwed things up. Well, it made things more complicated. So this becomes log of 24 plus x log 6 plus 2 log 6. And you could feel free at any point in time to write 2 log 6 as log of 36, because I can move that 2 up top, equals x log 2 plus 3 log 2, and be careful with the 3 log 2, you could feel free to write that as log of 8, because 2 to the 3 is 8. I'm going to move the x terms to the right side, because if I move the numbers to the right side, I create a whole bunch of extra negatives. Well, not a whole bunch, but I get more negatives because I have more of those terms that are positive on the left. So I'm moving this term to the other side, which means I have to take this term and move it to the other side. So on the left side, I have log of 24 plus 2 log of 6 minus 3 log of 2. And this is equal to the x log 2 minus x log 6. Now, Leslie, this is where we factor the x out to get a single x. So it's weird. Once you move the exponents down, you expand, which is the opposite of factoring. You move your x terms to one side and the others to the other side, then you factor, which is the opposite of expanding. So I can factor an x out of these two terms and be left with, in brackets, log 2 minus log 6. And this is something that I see students do sometimes. I didn't do it intentionally. My brain literally skipped a beat there. I put the 2 as a base, and that's not what it should be. It's not a base 2. It's log of 2. This is equal to the log of 24 plus the 2 log 6 minus the 3 log 2. And that thing on the left-hand side, log of 24 plus 2 log 6 minus 3 log 2 is just some number. So what we have is some number equals x multiplied by some other number. You divide the coefficient of x on both sides to have log of 2 minus log of 6 on the bottom. On the top, we have log of 24 plus, I'm going to go log of 36 minus log of 8. So I'm moving these exponents up top. I'm saying 6 squared is 36, 2 to the 3 is 8. Should I simplify the bottom and write log of 2 over 6? I wouldn't, because 2 over 6 is a fraction. Who needs that? Should I simplify the top? Ask yourself what would happen if you took those 3 logarithms on the top and packed them together as a single logarithm. I think you'd get a single logarithm of a number that's not a fraction. I think the number is going to be 108. Because that top will be log of 24 times 36 over 8. 24 over 8 is 3. No fractions. It reduces nicely. And 3 times 36 is 108. There are other things we could do with this, but I'm going to end the lesson here because I want to give you at least about the 25 minutes remaining to work on the assignment. Once I stop and get you going, I'll end my recording, and then if you're interested, I'll show you one other thing you could do here. Okay. Actually, I might even leave it in the recording. Page 34 of the handout, number 1 and 2, page 412 of the textbook, number 2 and 7. My thought here on this is that the reason I don't want to put those two logarithms in the denominator together, for those of you that are interested, is I will get a fraction. But, if those two numbers on the bottom were switched, if it wasn't log 2 minus log 6, but if it were log 6 minus log 2, then I would have log of 6 over 2, which is log of 3, which is very nice. So how do I do that? Well, what I could do is factor a negative out of the bottom, and the log 2 becomes negative log 2, and the negative log 6 becomes positive log 6. And then I can choose to put that negative wherever I want. Maybe I'll put it right in front of the whole thing, and I'll have log of 108. And on the bottom I can put these together as a single argument, which would be log of 6 over 2, because this is a positive and this is a negative log, which is log of 3. So there's a very tidy way to write our answer. By the way, you cannot divide 108 by 3. There's no rule for dividing logarithms. There's a rule for a log of a quotient. So, page 34, 1 to 2, 4, 12, 2 and 7.